So hi students, how are you? Today let's learn trigonometric functions. All right. So so we've been learning trigonometry since 9th standard, right? And I don't know how much all you know about trigonometry, because we used to learn a lot of like sine theta, cos theta, tan theta, like a lot of things, like, and we'll say like sine theta is equal to opposite side by hypotenuse, and cos theta is equal to adjacent side by hypotenuse. A lot of things we've been learning, like, and I don't know, like, since my childhood days also, I used to think like, why are we learning these things? What is the need of trigonometry in our life? Like, are we gonna apply these things in our life? So I got confused, and there is something that you should know about trigonometry. It's like a very useful thing in your life, and if you're going for further studies in engineering or anything, it's in physics or like any chemistry also, it's like really useful. So let me tell you like some like real life examples of trigonometry. Okay, so suppose in a situation, like, just assume the situation. Okay, you are standing here. Okay, you're standing here, and someone asked you to measure the height of this building. Okay, this is just suppose it's a Burj Khalifa or something. Okay, like really hard to measure the height, so you cannot just use a measuring tab to build just measure the height of this building, right? So this is like really hard. So the thing you can do is you can just go stand over here like this. Okay, and you can use a measuring tab. Okay, and first of all you have to mark this place where you're standing, and from here to the bottom of the building, okay, you can measure the length, right? You can measure this length by using a, what we say, a measuring tab. It's fine. You can measure this distance. It's fine. You're not like too far from this building. You can measure this distance. That's fine. And there is an instrument called Theodolite. Have you heard of this instrument? This is called Theodolite. Okay, have you? I think you must have seen this instrument with civil engineers and all, or those who are working in the roads, and also they are like measuring the distance, angles, and all. Okay, so you must have seen this instrument with the engineers and all. It's called theodolite. Okay, this instrument is actually used to measure the angles. So what we can do is we can just place a theodolite where we are standing, like we are just placing it in a tripod and all, and from this instrument like a laser is passing. Okay, a laser beam is passing. So through this instrument we can actually look at the points directly. Okay, so what we're going to do is like we'll just adjust this, and we'll just look at through the point so that we can see the top point of this building. Okay, so when we look at through this camera, you can see the top point, and laser will touch this point, and it will measure an angle from this point. Okay, from this base point it will measure an angle. So you can get any angle like 60 degree, 80 degree, 70 degree, 35 degree, 45 degree, any angle you can get, and it will just displace the angle. Okay, it will just display the angle. So that's it. Okay, so we'll just make it clear with an example. Okay, so suppose you're standing from this building about like 3 meter apart. Okay, just suppose, okay, you are just standing from this building like 3 meter apart, and you don't know the angle, so you are supposed to find the height of this building. Okay, and what you're going to do is you can measure the angle of this building using this theodolite. Okay, and you will get an angle, like suppose you will get an angle theta to like 60 degree. Okay, and so that we can find the height of this building. Okay, so let's see how we can use trigonometry to find the height of this building. Okay, so in trigonometry we have learned like a lot of things, right? Like sine theta, cos theta, and tan theta. That's like the basic things. So which thing we can apply here? Let's see. Let me take tan theta. What is tan theta? Tan theta is equal to, we have learned from 9th standard, right? What is tan theta? Tan theta is equal to adjacent side by, you know, opposite side by adjacent side, right? Tan theta is equal to opposite side by adjacent side, right? So you got tan theta. So let's see what is the opposite side over here. Opposite side is like h2, right? This is a height that we need to measure, right? This is h2. So you'll get like, let me write that annotation, h2. Okay, opposite side. And adjacent side, this is like opposite side. Okay, what is opposite side is like this is a theta, right? 60 degree. The just opposite side of this theta is h2, and adjacent side of this theta is x, or 3 meter, that we got right now. So we can write here over x or 3 meter. Let me write 3 meter. So tan theta is equal to h2 by 3 meter. Anyhow, the theodolite have given us the angle theta, right? That's 60 degree. So let me write tan 60 degree. Okay, that's what we got. Tan 60 degree is equal to h2 by 3. That's what we got, right? h2 is something that we need to find, and 3 is the length that we got by using a measuring tab. And let me tell you something. What is tan 60 degree? We will learn what is tan 60 degree. What is tan 0 degree? What is tan 30 degree, 45 degree, 60 degree, and 90 degree? These all are the things we learn, right? Tan 0. What is tan 0? Tan 0 is 0. Tan 30 is 1 by root 3. Tan 45 is 1. And tan 60 is root 3. And tan 90 is not defined. This is what we learned. Okay. So from this value we can get tan 60 as root 3, right? So let me write tan 60. Let me substitute this tan 60 with root 3. Okay, root 3 is equal to h2 by 3. So that from this equation we can just equate it and just find what is h2. From this we'll just take this 3 over here, and we'll get h2 is equal to 3 root 3. Okay, so that's the height of the building. Okay, that's the height of the building. That's not actually the height of the building, right? This is h2. It's like from here to here, that's h2, right? Not from here to here. So this is the height of theodolite. Okay, this is the height of a theodolite that you can measure using a tap, right? So that's it. This height of the building is h2 plus something that you will get. That's it. So it's easy, right? You got an application. What is trigonometry and what is the in real life that you can use trigonometry, right? And I'll just show you one more example. Okay, I'm not going to solve this again. This is like really boring. So let me tell you, this is like an application. Okay, so suppose like a flight, like a pilot who's just flying the flight like this. Okay, pilot is flying the flight and he's like coming back to home. So he's coming, right? And this is like the airport. Okay, this is the airport land. Okay, this is airport land, and he wants to land the flight over here. So what he need to do is he need to find from where, at which angle he need to make an inclination, that is called angle of descent. Okay, that is called angle of descent. Okay, this is called angle of descent. So he need to find what is the angle of descent and from where he need to make an inclination that he can land the flight. Okay, so because he cannot just land the flight like at a 90-degree, right? Or he cannot just drop the flight like this. He need to make an inclination like this, so that the passengers inside the flight won't feel like too much worried or something, right? So it should land like in a smoother way. So he should find the best angle for the descent. So for that, trigonometry is used. All right, you can see these things. Let's learn something else. Okay, let's learn how to convert degree to radians. Okay, so let me tell you, we've been learning like 60-degree, 90-degree, a lot of degrees. Like in a protractor we've been measuring these degrees, right? So there is like a new measurement that like we are going to learn, like it's in radians. So what is radians? Is it 1 centimeter a radian? Yes, these all are radians. Okay, this is 1 centimeter, all are radians, and 60-degree, 90-degree, all are in degrees. Okay, so we need to find how to convert this degree into radian. It's quite simple. Let's go and learn. Okay, so it's an easy method. So what you need to do is just take 60-degree. Okay, you need to convert this to radian. All you need to do is just multiply it with pi by 180. Okay, this is super easy. All you need to do is multiply it by pi by 180, and let's see what we'll get. We'll just cut the 0 and 0, and 6 will, we can cut 6 and 18, right? 6 will, it will go like 3 times, like 6 into 3 is 18, so we'll get pi by 3. So we found that 60-degree is pi by 3 radians. Okay, 60-degree is equal to pi by 3 radians, and let's say we need to convert pi by 3 radians into degree. Okay, just the opposite thing. So all you need to do is the same thing with the reciprocal. Okay, so pi by 3 degree into radians into degree. Okay, all you need to do is just multiply it by 180 by pi. So this pi and pi is going to cancel, and 3 is going to cancel with 18 by 6 into 3, right? I mean 6 into 3 is 18, right? So you'll get 6 and 60 degree, and you will get 60 degree. So pi by 3 radians is 60 degree. So I've seen like you'll get confused with, should I do pi by 180 or 180 by pi? Like you'll get confused. So all you need to like understand is, like, you got a degree, right? You need to convert it to radians. So most probably in radians there will be a pi. It will be like pi by 3, pi by 6, pi by 4, something like that. So in a radian there is a pi. So if you are asked to convert 60 degree into radians, just think of it like you need to get a pi. Okay, so pi will come in the numerator, and there is a 180, so obviously it will come in the denominator. So it's super easy, right? So if it's a degree, you need to convert it into radian. You need to get the pi in the top and 180 in the bottom, right? So you'll get radians. So just in the opposite scenario, how it will comes, you need to convert pi by 3 radians into degree. So you need to convert pi by 3 radians into degree. Just think of it like in degree there won't be any pi terms, so you need to cancel the pi. So the pi will be coming in the denominator, and obviously 180 will come in the numerator. So this pi and pi is going to cancel, and you will get a degree value. So just remember it, like you don't need to just by heart it, like in radians to degree, you need to divide it and multiply it with by 180 pi. You just get into the sense, that's a common sense. Okay, so it's super easy. So thank you for watching.